Okay guys, welcome back to another session in our tutorials. However, at this stage, the thing that we are just going to talk about is going to be a continuation of the thing that we discussed before. We had two very important levels in our group variations when we talk about, for example, the normalized whole brain volume with respect to the age. That it was our interest. One of them was, let's say, for example, in the random intercepts, we said that this one is going to be, for example, the case for, let's say, non-demented and also we introduced another one which was essentially parallel exactly to the non-demented one, and we call that the demented case, the demented level within the group variation. And for both of them, as we saw that they are just going to be parallel, as you remember the thing that we saw, we said that these intercepts, that's why we call that the random intercepts, because for the case of non-demented, we got the B0, let's say call it B01, and for the case of, I should say, the demented case, we got that B02. And as I'm going to emphasize is that these two are parallel. It means that if they are just going to be parallel, they have the same slope. Let me choose another color and choose this one. Let's say that, for example, if that's going to be, let's say, the alpha, this one is also going to be alpha, which that's why I mean that these two have the same slope. Which essentially what we talked about that before was that we look into the case that the brain atrophy from the age of 60 all the way to the 98 years old, although these groups at the age of 60 they have different brain volume, and from the age of 60 to the age of 98 with the same rate are just gonna experience the brain atrophy and the reduction in the brain volume and the brain size with the same rate. Then in that case, we may come and ask ourselves that what's going to happen in the case of the demented cases? What's going to happen if, for example, someone is diagnosed at the age of 60 with the dementia and the Alzheimer? Can we expect that the brain atrophy in that group is going to be much faster in terms of their variation and the rate of change compared to the case that it's going to be non-demented? What do I mean? I mean in that case, we can just look at that into a separate and a different, I should say, plot. I'm just going to call that again the horizontal axis. I'm just going to call that the age, and the vertical is the normalized whole brain volume. And we come to say that, okay, for the case of, I should say, the non-demented, we just start again from the same intercepts, which we call that B01, the same value as we had it for here, and we have this slope. As I said, it's becomes the non-demented case. However, for the case of, I should say, the demented, we expect that all the way starts from the same intercepts as before, as we call that B02, but they are not going to be parallel again, I should say, this regression line, because we expect that, for example, with the demented case, we hypothesize that this one is going to be this, it's going to occur faster. We are going to say that it's going to be the slope is going to be much, I should say, more drastic. Then if we can say here, the angle is going to be the alpha, we say that the angle here is going to be beta in a case that we say that the beta is going to be greater than the alpha, which denotes that at the age of 60 all the way going to the 98, it means that the rate of the change and the level of the brain atrophy for the case if the patients are demented is going to happen much faster compared to the cases that they are non-demented. Then we can hypothesize two cases. For the case one, which is going to be, I should say, the null hypothesis, we say that the rate of the change and the brain atrophy in two groups of the demented and non-demented, they're just going to be the same. However, for the alternative hypothesis, it becomes, I should say, the null hypothesis. And for the case of the alternative hypothesis, we say that no, there is going to be a difference in the rate of the brain atrophy between the non-demented and the demented cases. And depending on the value which we case we get, we're just going to expect that to see which rate is going to be faster and bigger than that. And essentially, that's going to be the intuition of what we are just going to do at the next tutorials when we just want to start to write the stand model for this, when we have two cases in our mind. Then we just go back to the stand model. We have two things changes. We have, I should say, we extend from this case. We expand from this case, which is going to be from here to there. We say that, okay, for the random intercepts, we expect that the random intercepts goes to, I should say, the random also slope, and we extend from this one to just go to that one, and the case two things are going to change. First of all, the intercepts are going to be varying and changing, and that's what we call that the random intercepts, which is the extension from this one, with the same thing that we got from the previous model, and also here, the slope is going to change. Then when we just go back to just work with the stand model, we take care of two things: the random intercepts and also the random slope. Okay, at the next tutorial, I can't wait to see you back, because we're just going to do something more fun, as we're just going to run our stand code to incorporate the variations of the intercepts and the slope.